Welcome, everybody. We'll just get everyone wait a little bit to get people logged in, and then, of course, just some reminders on the screen. And you could take this waiting time if you're not already to sign up to our mailing list. Stretch that waiting time
I
a little.
know you guys do a lot of agriculture in Alberta, so I'll ask you an agricultural knowledge question.
Uh-oh.
So why does a chicken coop always have two doors?
Don't know this one.
Because if it had four doors, it would be a chicken sedan.
Can we make sure that's in the recording?
Unfortunately, yes. Oh, I got a chuckle. I got a chuckle in the chat.
Maybe I'll throw an LOL in there.
Uh-oh. They've asked for more. Are you sure? All right. So you guys have heard of Android phones, I'm sure. And Android watches. If you buy a Tesla, you've actually got an Android car. But you know why there's no Android boats?
No.
What is that?
It's because when they come within Wi-Fi range, they sync automatically.
You didn't know, but you were getting stand up when you signed up for this webinar. Okay, welcome everyone. We'll still, I feel like, yeah, there were still quite a few more registrants, so I just will, oh, how close are we to 5 after? If it's okay with you guys, I'll wait until 5 after.
Sure. Phil, you're on a roll. Give us a third one.
Oh no, oh no.
Yes,
Let's see, why does a tiger use stripes for camouflage?
Unknown.
Well, it's so it won't be spotted.
Beautiful turn of phrase. Jeopardy music.
All right, Ignacio, you have to sing us a sea shanty.
Believe me, you don't want to hear me singing.
All right, 5 after. I think we should, yeah, be respectful of everyone's time that's here. So thank you so much for joining us. This is our next in a series of webinars where we're educating people about, we started with Embodied Carbon 101, and then we covered life cycle assessments and then also environmental product declarations. And so then we're really happy to have a presentation on the EC3 tool today. I think the more people get exposed to these free options or see what people are already doing in the industry, the better. So we're really, really happy to have this as our subject today. So just a quick reminder about CLF Alberta. We are new, we just started. Our mandate is to try and bring that carbon education to industry professionals, whether that's engineering, architect, policy makers. You know, we're aiming to cover it all. We really think that this change can come from all areas, and the more you know, the better. You can see we have our website there, clfalberta.com. So that has all our past recordings of the events if you want to catch up and weren't able to make it. And then we'll make sure to record this one too and send it out and post it. Also, in addition to our website, the CLF Alberta one, there's the carbonleadershipforum.org. And that one actually has a great amount of information regarding any topic. You can look up EC3, you can look up, you know, does my HVAC system impact embodied carbon? You can look up all those questions that you've ever had about a project and its carbon. Someone might have asked it, so you can see some information there. I think that's it for now. We're oh, sorry, I'm going to launch a quick poll though. We want to see where you guys are coming from, so I will just launch that quickly. We're trying to make sure we hit all our sectors, so. And I know it's not the most comprehensive list, but we tried. Okay, great. Architects and suppliers are leading the way today, but happy to have quite a few areas represented. We'll have to work on our general contractor next time. Maybe they're the late people. That's okay. All right, thank you for that. And with that, I'll let Ignacio introduce Phil. Ignacio.
Thank you, Kristen. It gives me really great pleasure to introduce Phil. Been working together now for a better part of the year and have gotten to know him fairly well. Phil Northcott is the CEO of Sea Change Labs and the co-creator of Embodied Carbon in Construction Calculator, better known as EC3, which is a free database of construction materials, EPDs, for use in design and material procurement. Originally an electrical engineer, Phil founded Sea Change Labs in 2017 to bring the power of cloud computing to the fight against climate change. Sea Change Labs works closely with nonprofit buildingtransparency.org, construction professionals, industry leaders, and building owners to build up the ecosystem of science-based open access information about the climate impacts of materials. He's based in Coquitlam, British Columbia. So without further ado, I will pass it on to Phil.
Thanks, Ignacio. So those of you who are new to the CLF might be interested to know that EC3 actually grew out of a project by two members of the CLF who had met there, Stacy Smedley of Skanska, a general contractor in Seattle, and myself, a software development CEO out of Vancouver, BC. And after being incubated by the CLF over the course of a number of, or the course of about a year, we founded buildingtransparency.org, which is a nonprofit, which is now, you can see the board of directors is a group of kind of the original visionaries like Don Davies, Lisa Conway, Kate Simonon of the CLF, and of course me and Stacy, and then some large group of large building owners, Google, Salesforce, Amazon, and Microsoft, and Facebook, as well as the technical director at Kieran Timberlake, who was the producer of Tally, which recently joined Building Transparency as part of one of our programs. So we make what are essentially enterprise grade tools for free. They're not really free tools. What they are is paid for. And this is the list of some of our brilliant sponsors who keep the lights on and make it possible to do what we do and offer everything we do for free. And by the way, that is intended to be permanent. We will offer this for free for as long as ever we can, because the objective is to move the industry as far as possible and remove as many barriers to action as we can. So I'll let you just scan that list, but these are the people who make our work possible. EC3 itself is a free tool. Let me just, I don't know quite why it's doing this, but no, it's being annoying. Here, let me just log in here. So this is a tool that you can use, and I'm just gonna vanish this to give us a little bit more room. It basically consists of four things. There is a large database of materials, and those materials are most especially concretes, because we have automated systems for bringing mix specific designs into EC3, and including Ignacio's group that's working with us on that. So for example, we have about 42,000 of them spread around the world, primarily in the US, but plenty in Canada as well. And even another place they've done a very good job is New Zealand. The In terms of the materials we cover, concrete, interior finishes, insulation, data cabling, cement and other manufacturing inputs, glazing, steel, and so on. Some of the areas that we are most interested in expanding in, things like cladding, masonry, wood, aluminum. Those are some areas where we're looking for significant increases in the availability of data. The way a customer interfaces with this is a consumer professional is, for example, let's say they want to source a concrete. So the first thing you want to know is, what is the basic performance characteristics, starting with compressive strength. Every one of these categories has different performance characteristics, and we work with industry professionals like Ignacio, and also like, I think Lori is on here as well. But there's a few of you on the list who've given us input. Anyway, they guide us as to what are the important product characteristics. You might also want to know where the thing is. So I'll take, for example, Washington State, which is where we have the biggest sample set. And if you search, what you're going to get is, in this case, there are 372 actual EPDs that match, plus a number of industry EPDs, which are kind of generic products documented by industry bodies. This gives you some statistics. What it tells you here is that most products are somewhere between 312 and 560 kilograms of CO2 per cubic meter. If, by the way, you prefer US units, you can go in here and switch to US units instead. We do all the conversions for you. If this seems like a very large range, it is. It's also the reality. Depending on how you mix a concrete, you can make a huge difference in the embodied carbon impact of that material. What's going on here? Part of what's going on here is that when you make concrete, the key binding element is cement. And the primary thing you do to make cement, it's more complex than this, but this is the primary thing, is you take limestone, calcium carbonate, you heat it until it splits into calcium oxide, quicklime, and CO2, which goes up the stack. That basic equation for ordinary Portland cement is one of the key drivers of the impact of concrete. Using smarter formulations and using higher performance concrete but less of it are excellent ways of reducing the overall embodied carbon of a building. Some of the things that people like Ignacio do is they put in things like fly ash, ground granulated slag, natural volcanic ash, finely ground limestone, finely ground glass. If you understand the chemistry, which the concrete guys do, there's a lot you can do to be more efficient in your use of the ordinary Portland cement, which is the part of the concrete that is highly carbon intensive. But this gives you an idea, without knowing any of that, of what's possible and what you might be able to spec. If you take a look inside any one of these, you will see a digitized EPD. So this is a record of one environmental product declaration by a particular company. It's got a particular SKU. This one is a 5,000 PSI, 3/8 inch aggregate with a 6-inch slump. It's got, and you'll see that we've converted these numbers to the currently selected units. If you were viewing this as a US person, this would show up as 5,000 PSI instead of 34.5 megapascals. Okay. And you can also see how it lines up against other things in its class, right? So you can see this is a fairly efficient mix. You can see the product category rules, which are the rules by which this analysis was done. You can see the program operator, the people who did the original who did the original analysis, who verified it. You can see exactly where the plant is. And of course, you can get the original EPD. We have digitized very large numbers of these PDFs, which are essentially, paper copies, in order that you should be able to do things like, and let's go back into this, do that same search, say 30 megapascals this time, and let's go in Canada. Okay, we've got 86, and you can do things like compare by manufacturer. In this case, there is just one that returned from this particular search, but there's lots of different mixes. You can compare by plant. You can compare specific different products to each other. One of the things you might notice fairly frequently around each of our things is this kind of blue fuzzy stuff around the declaration. What's going on here is that when people do life cycle analysis, you don't get a single precise number. They give you a value, but in fact, often the error is plus or minus 20, 30, 40%, depending on how specific the data was that was used to go into the analysis. We actually gather the information on how specific the data was behind these, and vary the amount of uncertainty depending on how specific the data was. In the best case, you're going to see manufacturers using, for example, data on very specific cements. And when that happens, what you're going to see, and I'm just going to check this here. I'm going to go to Central Concrete. And when that happens, you're actually going to see nice tight bars. And we have a methodology for ordering these that incorporates a combination of the uncertainty and the reported value to give you a single number, so we can order them in a list that we are 80% certain is not an underestimate. We can do very similar things with steel, searching by tensile strength and galvanization and so on. We can do very similar things with insulation. Where's the insulation? Thermal and moisture protection, insulation. If you took a look at board insulation, for example, if you sort by, for example, let's say mineral wool board insulation, you can get the range of what's available there. Oops, I did something wrong here. Apologize. Let me just get rid of that for a second. I think we might have a date of issue problem. Oh, no, I have manufacturer Cadman. That's my problem. Sorry, it turns out that Cadman Concrete doesn't actually make any board insulation, strangely enough. Okay, so here we see you get about 40 results. And if you take a look at any one of these, you can see how it lines up. So board insulation, for example, is calculated a different way than concrete. It's actually calculated in terms of 1 square meter times a thermal resistance of 1 degree Kelvin per watt for a square meter, which is the RSI value. Why? Because if you double the insulation capability, you would expect the the reason you're putting insulation in the first place is to get a certain RSI value. So it's kind of proportional to the job it does. So each of these things is available. You can get links that allow you to share these and put them inside documents. If you are the manufacturer, there's a page you can come look at. We encourage you to log into EC3 and take control of your own entry here. Putting in your logo, things like parent organizations and subsidiaries, and you can see all of your EPDs, all of your plants, and you can correct any of the data here that is incorrect. Acting as the manufacturer, you can edit anything on this side of the EPD, which is to say you can edit everything that describes what the product is. All of the environmental information is reserved to the program operator to edit. So I'm just going to quickly pause for a moment and see if there are questions so far. And please feel free to toss questions into the chat at any time. I see, Phil, is it possible to make your screen larger? What I can do is zoom in. Is that easier to see? I'll assume that's a yes.
Yeah, it's good. Better for me. Thank you.
Okay, so please, by the way, I've got the chat open. So if you have questions at any time, please go ahead and enter the questions in the chat. Okay, so in addition to the find and compare materials function, there is a cost planner built into EC3. It's essentially a general contractor's cost planner, but designed for accounting for carbon instead of accounting for dollars. So it starts with some demographic information, including in this case, a project address, which is important because you can do things like search by distance. It's very helpful if you can describe the level of development of this particular project, talk about the scope. Is this new or is it a renovation? Describe things like the floor area. So it's possible to compare with other buildings. And then what you do is pretty straightforwardly, you have something like, 13th floor steel deck. And then you might search for a material, steel decking. Okay. And then you would do a search. Okay, and you get kind of a range of results. You can choose a particular material if you like. I've chosen one arbitrarily. Okay, so now we've brought in the steel decking. You might have a quantity, 123.45 times. Let's say I have a wastage of 3%, so I can multiply that by 1.03, and I get a certain amount of square meters of steel decking. And anything you can do in Excel, you can do in one of these formulas. Here it's in square meters. Oh no, I want it in square yards. Okay, it's in square yards now. And of course, we're taking the data. Data is fed to us in square meters. We just convert to square yards for you. And then you can edit this as you need to. Okay. And then you can see there's all kinds of other stuff in this template. You can then create reports. Oops, I better actually, I don't want to save this because I have, so let me save work. Okay, oops, sorry. I will actually reopen this without having done the edits, so you can actually see the result. Let's take actually example tower number 2, for example, which actually has some quantities. So then there's a number of reports you can generate. The simplest one is the Sankey chart. The Sankey chart shows you, columns, floors, and so on. Where is the embodied carbon? The top tells you what is a conservative estimate, assuming that you just pick a material for cost and performance alone. The lower value here tells you what's the achievable target, that there's at least 20% of the products on the market that would let you get this. The height, the difference there is your available savings. And you can view this by uniformat, by master format, or if you've imported it from a CAD tool like Revit, you can also view it in the Revit hierarchy. And then it rolls all the way up to the building as a whole. And you can also save this if you want to put it in a presentation, or you can just take a screenshot. Either way will work. And there's a bunch of different ways you can look at this. For example, if you like tree maps, we've got tree maps as well. Another thing we have is we generate nicely formatted reports, either kind of quantity summaries to check against other takeoff styles. The building element report is pretty much everything we know. If you want to take the data out of EC3 and work with it yourself, the lead report is exactly what you need to submit for the lead pilot credit. And this follows the lead rules instead of our recommended procurement rules. So that is a quick overview of the building planner. There's a bunch more stuff here. If you have EPDs you want to bring into EC3, you can use the import EPDs function that passes the data to us for us to digitize. There's a bunch of functionality here for people to manage data, including managing data that they are able to verify or that belongs to them as a manufacturer. You can also find almost every PCR in existence here. Wherever we're allowed to give you the download, we do. You can also, there's also guidance here on how to go about getting an EPD. So first, kind of some basic guides as to what all these things mean. And then, let's say you were looking for concrete, let's say make ready mix. Who can help me do this? It'll show you who does work in this space. So for example, here you can see Climate Earth is the sustainability consulting group that does most of these, and most of them are registered with ASTM. So this kind of gives you an idea of who works in this space, and you can pick from here who you would like to go talk to help you get an EPD. And my general recommendation is pick somebody who operates in your geography, who is a specialist in in your category, because every category is different and the supply chains are unique, and you want people who actually understand your business. And last but not least, there's a bunch of documentation we've built in describing how we do stuff. And we try to keep that updated from time to time as we improve things. And the CLF Seattle group is quite involved in kind of defining and verifying the work that we do. I guess I will make a last shout out is to the simple ways to understand this tool when you're working with it. The first is anywhere you see something that says tour like this, You can click on it, and you'll get a whole bunch of my documentation on how to use it. In some cases, it actually contains a walkthrough. It will kind of walk you through each step. The second thing to look for is tooltips. If you hover your mouse over almost any field, it will tell you as precisely as we can what it means and how to use it. And anywhere, so anywhere you can hover over it, we'll try to give you documentation as to what it does. Last but not least, down the bottom right, there is a button to report feedback to us. This is a great way to report bugs, to ask for new features, to comment on things. You can kind of mark up the screen. You can tell us, I tried to enter a value here, and then I couldn't save my building. Whatever the problem is, and you can go ahead and do that. And then these all come to us, and we normally try to deal with them quite quickly. So we encourage you to give us feedback all the time. This is a very user-driven tool. The most common reason why a feature exists is that we think it will reduce carbon, but the second most common reason is that somebody said it would be really helpful if the tool could do this, and we turn that around and do it. So with that, that's our quick overview. I'm good for questions, feedback. Is there a way to import an EPD? Is a question in the chat. Is there a way to import an EPD for a category that is not currently an option, for example, resilient flooring? So the answer is yes. If you use import EPDs for anything, we will bring it in. I will tell you that resilient flooring is on the cusp of being released. Sorry, I'm clicking on the wrong thing. Resilient flooring is on the cusp of being released. We in fact have quite a large number of resilient flooring products in here, and the Resilient Flooring Institute, the RFCI, has been super helpful in working with us in coming to understand how resilient flooring works, what its types are, and what we need to do in order to get reasonable comparisons of different kinds. Next question. Hopefully that answers Stephanie's question.
No, it actually doesn't. It could be my account. I don't have all those options you do of all the finishes. So like on my end,
that is true.
It only shows carpet as my only floor finish option. Yes. And I try to import it and it won't let me.
Yes. Okay. So what's going on? What's going on is we have a set of categories that are not fully baked yet, and they are pilot categories. So they're only available to our pilot users. Our pilot users are people who are willing to help us help work with stuff that isn't fully baked and are prepared to put in usually some funding as well as significant time to help us debug that. So for example, Perkins and Will, Turner, Microsoft, Amazon, there's a whole set of, and in fact, Ignacio's group as well, our pilot partners, and have more full access. Resilient flooring will be released in the very near future, just as soon as we get the final go ahead. And then it will be available to all users. Right now, it's only available to people who are, one of our pilot partners.
Is there a way for a company to volunteer to be a pilot partner?
Yep. You should contact Stacy Smedley at buildingtransparency.org. And if you, so yes. Are you a manufacturer? You're a...
I work for a design firm, and I am a specifications writer, and I deal with this all day, every day looking at EPDs, and so
We would
fortunately, like
love to have your
it's
input.
yeah, it's really limiting for me right now to be able to use this because I have my own repository of EPDs and I can't add it right now with like the account that I have access to.
Okay, can you send an email to either myself or do you have my email address? If you don't,
We
I'll
can link that to
put it
you.
in the
I'll
chat.
make sure that happens. Yeah.
Yeah.
Thank
I'll
you.
just put it here. Okay, that's me or Stacy Smedley at buildingtransparency.org. Okay, so Stacy is the executive director of the nonprofit. She's in charge of selecting pilot users, and she is but in general, spec writers like yourself are kind of core professionals in this space. So we definitely both want to support you and want to hear from you.
Thank you.
Ignacio said, could you please explain how burden of the doubt would or should be calculated for procurement purposes? Okay, so so I'm going to pick something that isn't concrete just because Ignacio isn't concrete. So the idea of burden of the doubt, you guys probably all know the term benefit of the doubt, right? So very much you think about how kind of the income tax system works. It works the other way. They assume you get no deductions, and then you prove that you do have deductions. And our system for combining declared values and uncertainties is done like that. So we know that things that are not manufacturer specific, there's a significant variation between one manufacturer and another. And when you buy a product, you get it from one manufacturer, not a generic industry. Same thing is true of plants. One plant versus another, they have different electricity supply, different efficiencies of their equipment. And so depending on whether they've got data from a specific plant or not, that gives you a level of certainty or uncertainty. Some people will issue an EPD, sometimes just for cost reasons, that covers a very wide range of products. Clearly, a 4 millimeter and a 6 millimeter glass don't have the same embodied carbon. One of those things has 50% more material than the other. So is it a product specific EPD? And of course, if concrete, is it a specific mix design? So anywhere we don't know something, we add a certain amount of uncertainty to the result. We widen these kind of error bars based on what we don't know. And one of those things is supply chain specific data. In the case, and that's especially important in the case of, let's say, concrete or cement. Is in the supply chain upstream. It's made by a different plant than the one that ships you the concrete. But generally speaking, people don't use the data from the specific cement. Most commonly, they use generic cement data, and that means a lot of information is lost. So what we do is we understand from the LCA models how much each of these factors affects the result for a particular industry. And then we evaluate each EPD for how specific it is, and we apply uncertainty bars around the number based on how specific that particular EPD was. And then, having generated a log normal uncertainty factor, we then take an 80% confidence line. So given all the uncertainties, we are 80% confident that this value is high. And then for comparison purposes, we generate a number. In this case, it is 8.04 kilograms CO2 per square meter. We are 80% confident that, if we had a magic crystal ball as to the actual emission of the thing that they shipped you, it would be below that. And why do we do that? Well, the reason is that ultimately people do have to make a list. They have to be able to sort and compare. And so we have to have a metric for doing that. And the comparison value we use is the declared number plus the amount for the burden of the doubt. And of course, as the systems, as people's declarations get more and more transparent, that burden of the doubt will get smaller and smaller until it essentially vanishes. That's how burden of the doubt works on EC3. Next question.
Fantastic. I don't see any more questions yet, so I might jump in and just ask. I thought for a moment there when you were doing the buildings, like when you were starting making a building one, that there was a report option. Do you have a sample report or sample?
I do.
What
I
gets
do.
what
Yeah,
gets
absolutely.
published at the end?
I'll just have to switch sharing because it's going to open in Excel, but yes, I do. So let me go to a public building here. Doodly-doo. Let's pick out, will be a good one. Oh, let's pick this one. This is a real building. It's been anonymized by its original user. So if I download a report, I'm going to do the building element report in Excel format, which is the nicest of the formats. We're just going to open that in Excel, and I'm going to switch my screen to show. Where's my Excel? Zoom is being annoying. I'll be right with you. New share. Here we go. Share. And to make that not such an eye chart, I will reduce this. Okay, so this is the element report. You can see it's for this building at this LOD. This is the area. And here you can see each of the different parts of this building. You can see what the element is called, what the material is. In this case, it's a material called 6C bicadmium in Washington, 6,000 PSI. The amount, here's the baseline, conservative estimate, realized value, which is the amount from the selected EPD, and what an achievable target would be. And we can also see the reduction from the CLF baseline. And if you've selected particular materials, they would show up here, complete with a link to the original EPD. You can get this in Excel format, or you can get this in just a raw CSV if your IT people don't like you downloading Excels. And there's a couple more options. One of them is a lead report. So let's just take a look at a different building that might be a good one for lead. Let's hope I picked one. So I'm not sure which one would be a really good example. Maybe this one. If we download the report, this one, by the way, this is interesting. This building was originally captured using Tally, and then imported to EC3 using our Tally import, which is part of the Tally tool. But if we grab the lead report here, open that. Okay, and I will switch sharing again. Okay, so here we have the lead report. What you'll see is, in this case, there's only the materials that are covered by lead, but we combine elements together if they're all the same. And you can see in each case, we've got the selected material, manufacturer, plant, and name, and then a link to the specific EPD, because you have to supply the evidence of the product EPD that applies. So there's the baseline, the realized value, and the reduction from baseline, which is what you need to report for the lead credit. And there's also a case where, in some cases it's in an industry EPD instead of a product EPD. And again, you get the link, but the treatment, of course, in lead is a little bit different.
Oh, great. So that was for the EPD credit, not necessarily the life cycle assessment credit though, correct?
That is the EPD credit. That's right. Yep.
Phil,
I will tell you, I will say just in general, EC3 focuses on construct design and procurement, not on the full life cycle. And that's a deliberate decision because that is the poorly served part of the climate change equation. When it comes to the structural materials in particular, which are the vast bulk of the embodied carbon of a new building, it's that upfront carbon that is not well handled by existing tools, and that's what we're seeking to give you guys tools to control and compete on. So there was another question coming.
Yeah, Phil, no, this is Ignacio again. I just wanted to maybe, if you can help. I've heard this question from a lot of people and concern and struggle when they start looking and embarking in this journey. They go as far as creating EPDs and start measuring. However, they have a hard time establishing a good baseline. Could you maybe elaborate on how to do that and any recommendations you can provide?
So are you talking about a baseline for a material or for a building?
For a material.
For a material. Okay, goodness. So I will tell you that establishing baselines for materials is fundamentally hard. A typical use for a baseline is that you want to set a number that is, relevant to kind of compare things against and talk about reductions from. But the challenge is that, if you have a baseline for, let's say you have a baseline for aluminum. Well, there's the aluminum that you need on your skylight, and there's the aluminum that you need on your airplane, and they're not the same thing at all. You try for a baseline for all concretes, but there's one requirement for something that is heavy and won't move too much and will anchor your a building in an earthquake, and quite another for the one that's holding up the building during the earthquake. So that's the great challenge of baselines. We work with the CLF to try to generate relevant baselines that are, for example, sensitive to things like that are sensitive to things like strength. But it's a fundamentally challenging problem. What we primarily recommend, and this is just Phil talking, is that if possible, your best bet is to check your, figure out what your performance requirements are, get the achievable target, and see if you can get close to it or beat it. That is my personal recommendation, because ultimately, in order for our civilization to continue, we are going to have to end up here. Okay, that's not possible today, but we can get from here to here, and then the next set of competition will be to get to here. Next set of competition will be to get to here. My recommendation is see if you can get close to this achievable target. But if not, you can either use the CLF baseline, which are their course, right? They only know so much about your spec. but they are useful if you want to have a line that doesn't move too much, or if you like, you know, down from high baselines. This conservative estimate, which is 80% of the products are better than this, is not a bad place to start. But the simplest of all, I'll come back to, is this gives you a line to shoot for. We know it's possible because 20% of the markets can make it. So go talk to your supplier and see what they can do. Because especially in custom things like structural members or concretes, your suppliers know how to do this. Often they just need somebody to ask.
Thanks, Phil.
Great. Thank you so much for that reminder. I know I needed that for reminding me that it's about procurement when I'm trying to make sure I know where all the tools fit in. So I think that I know for me was an important takeaway. So thank you.
So there's one other comment I'll make, since we seem to have a tiny bit of time, is that there are a new set of tools coming out that we are developing for importing designs direct from CAD tools like Revit. So either via the Tally tool, or we're developing a next gen called TallyCat. That is quite a useful thing to do. But in general, I will say anywhere you can get estimates for a building that are good enough for cost, that's your best source for the data that you would want to put into EC3 to track on the building. And I will say it doesn't take very long to actually do this. Stacy actually had her then 9-year-old son actually do one. Let's see if I can pull it up. It's called Chuck's Lair. So it's actually, it's probably under shared with me. I don't want to show that because I'll show stuff that doesn't belong in the public. But the what was I trying to say? It is not actually difficult to manually enter this stuff. Stacy can do a building in about 15 minutes now. And once you've done it, you can use quite powerful sharing tools, very similar to Google Docs, that allow you to share with your architect, your structural engineer, and so on. And you can work together to refine the products, or refine the building, and find where your savings are, and report to management.
Amazing. Okay, we are definitely on time. So now's the time for questions. Everyone's going to be an EC3 expert, sign up, but it is a free tool. So definitely just encourage you to sign up and just poke around at least.
Absolutely. Well, if there's nothing more, I'll say thanks very much for your time. I hope this has been informative. If you want to find out more, please come to buildingtransparency.org. And we are available to be in contact if you need assistance.
Fantastic. Thank you, Phil. And yeah, encourage everyone to check out that the website. I'm getting used to the Zoom reactions. Thank you, guys. Great. Okay, so for CLF Alberta, there's a question. It will be available for people who join. Yeah, we'll make sure to post it on our website. And then if you did register through it, we usually try and send out a copy specifically to the mailing list as well. So, for the registrant list. So absolutely, we'll make sure you can get the full presentation. Yeah, because that beginning part was great. And yeah, there were some great dad jokes at the very beginning. For CLF Alberta, we are going to do just a bit of a summer break. Want to kind of give everyone a break from Zoom fatigue, and we'll make sure to be ready to go in the fall. So we're working on exciting presentations around the circular economy, and also with potentially some policy updates from municipalities. So we're working on trying to get some exciting speakers for the next round of webinars. Again, I'll just remind everyone to sign up to our newsletter. I lost it in my share screen here, but it is the clfalberta.com. Oh, did that work?
You're sharing your full screen.
Oh dear. Sorry. Stop share.
That, Phil, is a real.
Yeah, I think that's it for us. So yeah, we encourage you to check us out on social media, check out our LinkedIn, and then of course sign up for our mailing list. You'll make sure to get all the inside track for all the events. Okay, that's it for now. Thank you, everyone. We're so on time. This is fantastic. Thank you, Phil.
Thanks, Kristen. Bye-bye.
Bye, everyone.